Hi, I'm KALAIMATHY GUNALAN from RY41. My matrix number is 20139151. Now I'm going to present the answers I get from the Lab 2 operational amplifier. For this lab, we have built two different circuits. One is inverting operational amplifier circuit. Another one is operational amplifier circuit. For the first circuit, we have used RF as 4.7k ohm, and I have used this formula to find out the gain for this particular circuit, and the formula is negative RF over R1. For this circuit, the RF is 4.7k and the R1 is 1.01k, so we're gonna divide and the answer will be negative. We will see why the formula is in negative in a while. So for the V out, we have used the formula gain we get from the calculation above times with V in. So for this circuit, my gain is negative 4.7 and times with 1 voltage as a V in, so the V out is negative 4.7 volt. So these are the calculated value for the gain and V out. So from the experiment we can see the value is 4.665 volt, which is almost similar to the calculated value. Here the value is negative because if the inverting operational amplifier, the power supply will be connected to the negative terminal in the operational amplifier, so the phase of the signal will be inverted. So here we can see the phase of the input signal is different from the output signal, is inverting. So that's why there is the gain formula as a negative on itself. So for the second value, for the second circuit, the RF value is 10k ohm. So we have used that value to calculate the gain. So I have derived the calculation and I got the answer negative 10. And the V out is from the calculation. Here the formula, we use the same formula as the above circuit, so the output is negative 10 volt. Here we have measured value from the circuit. The value is 9.925 volt, which is almost same to the calculated value. For the third circuit of inverting amplifier operational amplifier circuit, here we use RF as 33k ohm. So we have calculated the value, so the value is negative, the gain value is negative 33 and the V out is negative 33 volt. So here we can see there is a cut off clipped. It's because of the the output is exceeding the input common mode voltage range, which we can see here the voltage range is 50 volt for this circuit. So supposed to be the answer is negative 33 volt, but because we give the input as 15 power supply as 15 volts, so the result from experiment will be 15 volt because it cannot exceeding the common mode voltage range. So for the question, why the output waveform has been clipped, which we can see from here there is a cut off. So the answer is the output of waveform clipped because it exceeding the input common mode voltage range, which is 15 volt for this circuit. Here we can see that be supplied 15 volts, so the answer will be in 15 volt. It cannot be exceeded 15 volt. Why it is called as inverting amplifier? It's called as inverting amplifier because it produces an output which is out of phase with respect to its input by 180 degrees. So here we can see the difference between phases of input and output signal. It's totally opposite, so it's inverting circuit. For the second part, we're going to see non-inverting operational amplifier. The formula are not same for the gain. So the gain formula is 1 plus RF divided by R1. So I have used this formula to calculate the gain. Here we can see the calculated gain is 5.7 and the V out is gain times with V in, so we have times with 5.7 times with 1 volt, so 5.7 volt. So I have write down the answers from the calculation, and the measured value is 5.651 volt, so it almost same with the calculated value. For RF equals to 10k, we have used the same formula as above, and we have find out the gain is 11 and the V out is 11 volt. So from the circuit we have find the V out is 10.893 volt, so it's almost same with the calculated value. And for the third non-inverting amplifier circuit, the RF is 33k. So here we have used the formula as for gain, and then I found out the gain is 34 and the V out is 34 volt. So it have been write down here, and the measured value for this circuit is 15.058 volt. It's clipped off, is cut off because of the same reason that I have explained above. And for the question, why is it called as non-inverting amplifier? Because the circuit amplify the input signal without changing its phases. What does non-inverting mean? If a sine wave is connected to the operational amplifier positive terminal, it's connected to the, because the positive terminal is function as non-inverting input. So when we connect the power supply to the input's positive terminal, it won't invert the input, and the output will be same phase as the input signal. For the discussion, at the end of this experiment, I have learned to demonstrate an inverting and non-inverting operational amplifier circuit using multisim live, which we can see the results are in multisim live. Other than that, I have also learned to investigate the operational amplifier voltage follower. Next, I have learned to use the formula to calculate gain and V out of inverting and non-inverting amplifier circuit. For the conclusion, as a conclusion, the type of amplifier circuit is depending on the connection of input of the input terminals in operational amplifier. If the input supply connected to the negative terminal of the operational amplifier, the circuit will operate at inverting amplifier circuit, because this connection produce the output which is out of phase with respect to its input by 180 degree. If the input supply connected to the positive terminal of operational amplifier, the circuit will operate as non-inverting amplifier circuit, because it produces an amplified output signal, and this output signal is non-inverting operational amplifier is in phase with the applied input signal. Other than that, there are two different formulas to calculate the gain and V out for the both amplifier circuit. Thank you. That's all from me for this lab. So I have shown all my calculation and my circuits for two different amplifier circuits. Thank you.